Excuse me. All right, welcome to the Chapter 4 review. There's a few questions posted, so we'll just go through those. The first one asked to do 4.2, number 9. And it's a system of equations, and it says solve the system by substitution. We're given y equals 5/4 x plus 3/4. And my second equation is y equals negative 2/3 x minus 38/3. Okay? Not pleasant to look at right off the bat. It did tell us to do it by substitution, which is nice that y is already solved for not only in one but in both of these. And so I can just equate the right-hand sides. If y is equal to this and y is equal to that, then these two right-hand sides must be equal. So that's what I'll do. I am short on space in this board here, so I'm just going to rewrite this up here and say this right-hand side should be equal to that right-hand side. Right. And solve this. Right. I have an ugly bunch of fractions with a 4 in the denominator on the left, and an ugly bunch of fractions with a 3 in the denominator on the right, right? So I'm going to clear that all out by multiplying everything by 12, my lowest common multiple of the denominators. So multiply this by 12, that 12 of course distributes through, and I'll multiply this by 12, and that 12 of course distributes through. So when I multiply the 12 in here, the 12 will cancel with the 4 to leave me with a 3 that multiplies to the 5 to give me 15x. The 12 multiplies into here, that cancels again to leave me with a 3 that multiplies by the 3 to give me a 9. Okay. On the right hand side, the 12 distributes through, but it simplifies with the 3 to leave me with a 4, so I have negative 2 times 4 is negative 8x. And then the 12 again distributes into here, simplifies with a 3 to leave me with a 4. So I have negative 38 times 4, which is negative 120 plus 32. I just lost count. Negative 120, and then negative 32 more, so negative 152. Excuse me while I grab a calculator, and apparently I can't speak or do math today. Negative 38 times, what am I multiplying by 4? It's 152. Alright. Brain's still sort of working. I want to get all of these onto one side, so I'm going to add 8x. Now to get all my x's to the left, may as well kick this 9 out of the left, put it off to the right. So that gives me 23x is equal to negative 161. Divide each side by 23, and I have x equals negative, and I think that goes evenly. Negative 161 divided by 23 is 7, so it's negative 7. Right? Kind of ugly numbers there, but we've got it. X is negative 7. And I'm going to take this back up and plug it into one of the original equations. So clear up a little bit. Apologize, this is a little bit all over the place and messy. But x equals negative 7. There's no way in hell I want to use the one with a fraction with 38 over 3, so I'm going to use the other one because, yuck. I know if x is negative 7, I can solve for y by plugging it in, so 5/4 times negative 7 plus 3 over 4, right? I can't simplify here. There's no simplifying the 7 with the 4, so I just have to multiply. This becomes negative 35 over 4, and we still end up with an ugly fraction here, plus 3 over 4, and combine these. Negative 35 plus 3/4 is negative 32 over 4. But that goes nicely because that is negative 8. And that's it. So x is negative 7, y is negative 8. Okay, good. Let's see, 4.5 number 7 was also asked. Here it says solve by writing it as a matrix and then performing matrix row operations. So I have a system given to me. 2x plus 3y equals negative 9. And 4x minus y equals 17. Okay. So to write it as a matrix, again, we're just going to steal all of those coefficients and write it into a matrix like this. 2, 3, negative 9. And 4, 1, negative 1, and 17. Okay. Now this is that hard scenario where I can't easily get a 1 in my upper left without getting a fraction. And if you aren't afraid of fractions, by all means just divide everything in row 1 by 1/2, or multiply it by 1/2, divide it by 2, right? If you don't like that idea, move on to the next step and leave that 1 to the last. So let's get this 4 to be a 0, and I'll do that by subtracting row 1 twice. Or as I would write it, as I would say, take negative 2 row 1s and add that into row 2. That'll give me my new row 2, right? And then row 1 is just going to stay how it is. So row 1, leaving it alone, 2, 3, negative 9. Negative 2 times row 1 works because I've got negative 2 times 2 is negative 4, plus that 4 gives me 0. Negative 2 times 3 is negative 6, and another negative 1 gives me negative 7. Negative 2 times negative 9 is a positive 18, plus 17 is negative 35. Which is nice. Divide everything in here, divide that by negative 7, and that gives me 2, 3, negative 9, 0, 1, 5, right? Scoot up to this 3, I want to get rid of it, so I'm going to go minus 3 row 2s. Added back into row 1 will give me my new row 1, and I'm leaving row 2 alone. So 0, 1, 5. Negative 3 times 0 is 0, plus 2 is still 2. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 5 is negative 15, plus negative 9. Negative 24. I seem to think that that might be too big, but it might not be. I don't know. We'll try it. Divide the top row by 2, and I end up with 1, 0, negative 12, and then 0, 1, 5. There may be a mistake. I don't recall the number being that big, but let me plug it in and we'll see. I might just be right anyway. This is number 7. So I've plugged it in. The answer says that I am wrong. Shocker. So let's see if I can figure out why. I went negative 2 row 1s. negative 2 times negative 9 is a positive 18, plus the 17 is a positive 35. And so when I divide it by negative 7, this should be a negative, and that makes all of this wrong, right? I'm still going to go through that same operation here. And so at negative 3 row 2's, negative 3 times 0 is 0, plus 2 is 2. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times negative 5 is a positive 15, minus 9 is a 6. Right? And then I have 0, 1, negative 5 still. And then dividing that top one by 2 gives me my 1, 0, 3, which sounds more correct, and 0, 1, negative 5. And again, I can plug these back up into my original equation if I want. X is 3, y is negative 5, so 3 times 2 is 6. Negative 5 times 3 is negative 15. 6 plus negative 15 is indeed negative 9, so that checks out. 4 times 3 is 12, minus negative 5 is plus 5, so it's 17. That checks out as well, so I'm good. Good. All right. What else was asked here? Some more matrix stuff, it says. Let's look at 4-6 number 1 real quick. That was also asked. Four, 6 number 1 says graph, and so I have a system. X plus y is less than 2, and y is greater than or equal to 2x. Okay, that's my system. So I just graph each of these individually. X plus y is less than 2. I look for the boundary by saying x plus y is equal to 2. And I know that since it's a strictly less than, it's going to be a dotted line. Right? But I should be able to find this by intercept method. If x is 0, y is 2. If y is 0, x is 2. Right? So easy enough. 1, 2, 1, 2. It's a dotted line because it's a strict inequality. And then I just have to decide if I'm shading in this area or in this area, right? So I test a point. 0, 0 is my go-to as long as my line doesn't go through it. So plugging in 0, 0 into this original inequality gives me a true statement. So I want to shade where that 0, 0 is. Again, I apologize with these markers, it always looks pretty terrible, but I'm down in that region. Okay. The other one should be pretty easy, it's in y equals mx plus b format. Let me clear this out of here. The boundary is at y equals x, or if you like, y equals 1x plus 0. I know this is going to be a solid line, and it's solid because it's greater than or equal to. It has that equal, right? So this goes through 0, and it has a slope of 1, so it's just that slope of 1 line that goes like that. I need to test a point, but I can't test 0, 0 because my line goes through 0, 0. So pick another point, it doesn't matter where. Here's a point 1, 0. I'll check that. If I plug that into the original inequality, y is 0, x is 1, and that's false, right? 0 is not greater than or equal to 1, so it's false, so I don't shade in this area in relation to this line, I shade on the other, so that's above it, up here. And if you can still see what's happening with all of these lines everywhere, that looks, I guess it doesn't look terrible, but it's that section over there, right? So this is my solution area, right here. Okay. All right, are we okay with that? I don't know who I'm asking, you're not going to respond, but all right, I hope you're okay with that. Okay. Old habits die hard. Okay, let's do another matrix because I think some more matrices were asked. So let's go back to 4.5. And I'll do one, let's say, no, number 5, because why not? So 4.5, number 5, asks us to solve the system of solutions by writing as a matrix and then performing matrix row operations. I'm just going to go straight to the matrix here. 3, -2, -16, and 2, 1, 1. Okay. All right. So it's easy to take 3 minus 2 and get a 1, so I'm going to do that. That's row 1 minus row 2. Second row I'm not changing, so 2, 1, 1 still. Top row, row 1 minus row 2, so 3 minus 2 is 1. -2 minus 1 is -3. And -16 minus 1 is -17. Okay. I've got my 1, I'm going to use it to eliminate this 2. So that is to say I'm going to take -2 row 1s and add that into row 2 to give me my new row 2. Row 1 I don't want to mess with, so I'm not going to change it. This gives me 1, -3, -17 at the top still. And -2 row 1's added to row 2, so -2 times 1 is -2, plus 2 is 0, perfect. -2 times -3 is a positive 6, plus 1 is 7. And -2 times -17 is a positive 34, plus 1 is 35. I'll divide row 2 by 7 and leave row 1 alone. So that gives me a 1, -3, -17 still in my row 1, and a 0, 1, 5 in my row 2. I now want to get rid of this -3, so I'll use 3 of row 2's to do that. 3 row 2 plus row 1 is my new row 1. And row 2 is done, so 0, 1, 5. 3 row 2's, so 3 times 0 is 0, plus row 1, add that 1, gives you 1 again. 3 times 1 is 3, plus -3 is 0, perfect, my left is exactly where I want it. 3 times 5 is 15, plus -17 is -2, and I'm done. X is -2, Y is 5, so I have, if you want it as a point, it would be -2, 5, and done. Good. All right, hopefully that's helpful. Best of luck to you on your test, and I'll see you on the next one.